Okay. All right, there we go. Okay, Susan, your I don't know, your screen is black. Is it normal?
You don't. You see it?
No.
Weird.
Don't see it anymore.
Give me just a sec. Let's go back to Teams.
Yes, it's good. We can see the screen again. Yeah.
Okay, let's see. And start sharing.
The first page. Okay.
We're good.
No, it's gone to black again.
Really?
It seems that when you're opening, when you're activating the PowerPoint, it seems to go to black. I don't know, maybe.
Oh, that's too bad. Set up slideshow. Let's see. No.
Worst case, if it doesn't work, let me know. I will run it from my computer. But it would be better if it's yours. It's easier, but
exactly. Let me
I can see your screen now. Okay, now I don't.
Yeah, but it's it seems it's when she's activating the PowerPoint, the screen goes black.
That's weird. And you don't see it?
No, it's black.
I mean, or I could just show it like this. There's another option. It's not.
Susan, are you sharing your entire screen?
Yeah. Let me try. So I believe I am.
Because if you're only sharing PowerPoint, maybe that's the problem. I don't know.
Yeah.
No, I'm sharing through Teams. Let's see. It says hide.
But did you select the share screen or just share PowerPoint?
It says share content. There wasn't in Teams now. There isn't a share screen button.
Oh yeah, it's share content. Okay. Oh,
yeah,
it's
I chose share content.
But if you reduce that screen, what do we have?
Which one? My Teams or PowerPoint?
Because when you share with Teams, you can select which window will be shared, and so if you only selected your PowerPoint, maybe it's different. If you selected the entire screen, then I'm confused.
No, I selected the entire thing, so I did share content, and then it gives me a bunch of choices down here, and I choose PowerPoint.
Oh, you chose PowerPoint, but you can choose your screen at the far left.
Oh, you're saying oh. Okay.
Yeah.
Hold on, let's see. Go back here. So share content and
so now
screen.
Yeah.
On.
Yeah. Put it on PowerPoint. Yeah. Yeah, that's perfect.
Okay.
And you just might want to minimize the window, the black window. Yeah, exactly. Okay. Perfect.
I learned something new today. Okay.
Yeah, thanks, Susan. So I think we'll get started. So I would like to welcome everybody who joined this third part of our technical webinars on water stable isotope applications using the ABB LGR ICOS equipments. So the first thing I need to mention to everyone is that this webinar is being recorded and will be made available as usual within a couple of days on the ASN website if you need to share it or go through it again. Today's webinar will be given by our colleague Susan Fortson, based in California. Susan is product manager in San Jose, and she has quite a lot of expertise on isotopic applications. So the first webinar we had a few months ago now of this series was focusing on the ABB LGR hardware and software, which is being used for the various isotopic water applications. Then last month we had another webinar with a focus on the hydrology applications. And now today, Susan, we talk about the biomedical and energy expenditure applications, which are also very important ones. And several of our customers are using those equipments. So I will hand over the presentation to Susan, and as always, we will keep some time in the end for questions you may have. So up to you, Susan.
Okay. Good morning, everyone. So today, as you said, we're going to talk about water isotopes and biomedical and energy expenditure applications. We define total daily energy expenditure as the amount of energy a person uses daily to complete all regular body activities. This includes movement, breathing, and digestion. We measure this in calories, which is a unit of heat. It is represented by the symbol kilocalories. Energy requirements can vary widely from one person to another person, from person to person, and even from day to day and an individual. Analysis of hydrogen isotopes and oxygen isotopes in the human body is used for a variety of biomedical applications. And this can include measurement of total energy expenditure by the doubly labeled water method, also known as DLW, the measurement of total body water, and measurement of insulin resistance by glucose disposal, among other applications. The doubly labeled water method is the gold standard to measure calories burned in people. It is referred to as the total daily energy expenditure, or TDEE. The doubly labeled water method involves drinking water that is labeled with a safe, non-radioactive tracer. Both the hydrogen and oxygen atoms in the water molecule are either partly replaced or completely replaced with their stable isotopes, which is used for tracing. The differential elimination rates of the isotopic labels of both hydrogen and oxygen will then provide a measure of carbon dioxide production. After a person ingests doubly labeled water dose, the two isotopes equilibrate with total body water. They are eliminated from the body after a few hours. So deuterium leaves the body as water, and oxygen leaves as a combination of water and carbon dioxide. Urine samples can then be collected several days apart. By measuring the isotope ratios in the urine over several days, the carbon dioxide output can be quantified. The result is a measurement of the person's average total daily energy expenditure in kilocalories per day. So IRMS is what is widely used for analysis of water isotopes in body water. However, there's issues involved with this process, such as really labor-intensive preparation methods that require a lot of extensive purification of the samples. It's labor-intensive analysis as well. It's very costly, and there's actually only a few measurement laboratories around the world that can even do this. So in order for biomedical applications to become widely available, measurements of large number of samples must be completed both quickly, accurately, inexpensively, and preferably at a location near the site of where the sample was generated. Our analyzers, the off-axis cavity output spectroscopy technology, offers an attractive alternative. It enables direct measurements of body fluids with minimal sample preparation. It demonstrates superior accuracy over a wide dynamic range. ICOS determination of the TDEE is simpler, and it's less expensive to implement. The ability to immediately and inexpensively measure the stable isotopes of water and human water is expected to increase the number and variety of experiments which can be undertaken. So our liquid water isotope analyzers are equivalent to the gold standard IRMS in performance. However, ours are also much easier to use and operate and much cheaper. And packages can vary depending on the needs of the customer, but it'll typically include either our benchtop model or our portable liquid water isotope analyzer. It includes the post-analysis software and a set of calibrated working standards with a known isotopic composition, and also the optional auto-injector. So here are the advantages of our liquid water isotope analyzers. They're pre-calibrated, highly sensitive, and very stable. They can handle over 800 injections per day when they're paired with the optional auto-injector. They report relative abundance of hydrogen and oxygen stable isotopes simultaneously. They are robust against cross interference and matrix effects. They are easier to implement than IRMS, yet they still have the same gold standard accuracy. The included post-analysis software is capable of detecting and correcting for sample contamination. There's proven robustness. We offer a 2-year factory warranty. Very important is that they're field serviceable, so therefore on-site maintenance and mirror cleaning operations can be done there without requiring expensive and time-consuming factory repair. It's also capable of measuring samples with salinities ranging from 0 to 4, which is important when working with biological samples. Urine, saliva, and blood plasma samples require very little preparation. Volumes can range between 30 to 250 milliliters. There's one additional step for plasma and saliva that you don't have to do for urine. The proteins in plasma and saliva must be precipitated. So in order to do this, we add 5 milligrams of zinc sulfate monohydrate, which is added to the sample and mixed really well, and that will precipitate the proteins. So the plasma, urine, and saliva samples can then be centrifuged at 8,000 RPM for approximately 10 minutes. Between 10 milliliters minimum to 75 milliliters maximum of the supernatant, which is the clear liquid on top, is transferred to a vial for liquid water analysis. So now the samples are ready for analysis on the liquid water isotope analyzers. For data analysis, the biological samples should be interleaved between 3 water standards of a known concentration and similar isotopic range. The next 6 steps describe what happens during each injection. So first of all, the cavity is pumped down for 3 seconds to remove any residuals of the previous injection. Next, clean, dry air is filled into the cavity. The next 24 seconds is a pump down to remove the dry air from the cell. Now 1 microliter of the sample or standard is injected. There's a 3-second hold to allow for complete evaporation, and then the optical absorption spectra is measured for 30 seconds. So each injection takes a total of 90 seconds. It should be noted that salty and dirty samples can leave residue in the injector block and the transfer line as well, which could affect measurement time. So it's recommended to do frequent cleanings of the injector block when working with biological samples. So the next 4 slides were covered in our last webinar, but I think it's pertinent information, so I'm going to repeat them. And this is how to set up configurations on the analyzer to interleave standards and samples. So unknown samples are interleaved with the standards of a known isotopic value. That's the recommended configuration. We define an interleaved run as having standard and sample injection sets measured in an alternating order. So the image on the right shows an example of an interleaved data set with rotating standards in between samples. Each standard and sample injection group consists of 6 measurements. So you'll see the first 2 blue and 4 green. Please note also that this is these 6 injections. It's just an example, and it could vary depending on the sample being run. So the first 2 of the injections in blue are ignored, and the last 4 injections in green are measured. The run begins with 1 standard injection group, followed by 4 sample injection groups. And this pattern continues with 3 standards of different isotopic composition. So the ignored injections are the initial injections which will be excluded in the post-analysis software each time that a standard or sample is changed. This is done to mitigate any memory effects from the previous sample, regardless of any other issue with those injections. They function as normal injections, but the measured data will be excluded by the post-analysis software. Run configurations are dependent on what the customer wants. So some will be interested in high throughput mode, which is more samples per day, while others may require very precise measurement. In this case, the same sample is measured multiple times and averaged. Please see the table on the left, and this is high throughput mode. So sample 1 is injected 6 times, and the last 4 measured injections are averaged to provide 1 data point. In this example, 20 unique samples are measured. And listed below are the high throughput specs that the analyzer must meet or exceed. On the in the table on the right, you'll see sample 1 is injected 6 times, and the last 4 are again measured injections to average 1 data point. But in this case, the same sample is then repeated 10 times. These 10 data points are averaged to provide a high precision value. In this example, only 2 unique samples are measured. And again, listed below here are the high precision specs that the analyzer must meet or exceed. ABB's post-analysis software is provided with each liquid water isotope analyzer, and it's used to process the data. It's a powerful tool to provide a simple method of post-processing the data acquired by the analyzer. The post-analysis algorithm assumes that the analyzer run configuration was using standards of a known isotopic composition interleaved with the samples. The software calculates adjustments to the measured values of isotopes based on the differences between known and measured values of the standards. It then reports a processed value. So any number of interleaved samples can be measured. Although interleaved sample standard grouping is the recommended configuration, the software can accommodate other unique run configurations as well. Listed below are the functions of the post-analysis software. It can load standard data files. It performs all required standardization and processing steps. It exports the processed data to easily readable text files. It automatically checks for analyzer flags. It recognizes and tracks customizable internal controls. It provides optional data filters. It allows many different graphical views of the data, and it's also fully configurable. If the analyzer produces a poor injection due to syringe instability, a leaky septum, temperature fluctuations, or anything else, the post-analysis software can identify and alert the user of these issues using a variety of filters that are built into the software. And if the data is outside the bounds of the filter, the injection will be excluded from the calculations of the process data set in order to provide the user with accurate results. To summarize the advantages of the liquid water isotope analyzer, it does not require extensive consumables, trained personnel, high vacuum, or sample conversion. It requires low power, and the cost per sample is substantially smaller than competing technologies such as IRMS. In addition to benchtop models, the ABB portfolio includes the compact, portable, field deployable liquid water analyzer. And the isotopic water analyzers are rugged and designed to handle both natural and enriched waters. Users can leverage the precision and speed of our instruments by coupling them with benchtop auto-injectors to perform unattended injection patterns on multiple samples. And in the near future, we will also release a portable auto-sampling system that can be paired with the analyzers. So it has it's equal in performance to the gold standard IRMS. So here's an example of an application using our liquid water isotope analyzer to measure deuterium and oxygen-18 in both natural and enriched human urine. Analysis schemes were demonstrated to address sample-to-sample memory while still allowing analysis of 45 natural urine samples and 30 enriched urine samples per day. Performance was linear over a wide range of isotopes. Measurements of human urine were precise, as you can see listed here. The accuracy of the isotope urine measurements was verified to be better than plus or minus 0.81 per mil in deuterium and plus or minus 0.13 per mil in 18 against 3 independent isotope ratio mass spectrometry laboratories. The ability to immediately and inexpensively measure these isotopes in human urine is expected to increase the number and variety of experiments which can be undertaken. Expanding the scope of work, there are also additional energy expenditure applications unrelated to water isotopes that are being done, which use ABB's carbon dioxide isotope gas analyzers to study carbon isotopes. Pictured here is a setup for human respirometry tests for energy expenditure and carbon-13. You'll notice in the first image, our carbon dioxide isotope analyzer measuring a continuous flow of the isotope over time. So here's a list of scientific papers and application notes that you can refer to for more information. And I'm assuming we can provide these to you. And I just want to say thank you for taking the time to listen to this presentation.
Thank you, Susan. First of all, yes, going back to your previous slide on the articles, I confirm we can share those articles. Some of them have already been distributed with a monthly newsletter, but people who don't have them or who wish to receive a copy of those articles can send an email to me, and I will share the article. Before we open the Q&A session, I saw already there was a question from our friend Hans in Belgium, who was asking about the availability of the portable version of the autoloader. You might correct me if I'm wrong, Susan, but I believe we are expecting we're working with a supplier and we're expecting to receive a prototype by the end of Q1 2021, on which we will work and make adjustment and productize. So probably somewhere between Q3 and Q4 2021. Is that correct, Susan, for the availability? Yeah.
Yeah, that's the plan so far. I hope to, as soon as I receive it in Q1, I will work as hard as I can, because I know this is a very sought after auto injector.
Okay. So do we have other questions from anyone? I'm checking. Okay, no question. Feel free to unmute your microphones if there are questions. In the meantime, I have a question, Susan. Actually, so you mentioned that even for biological samples, in terms of pre-treatment, basically we only need to do, except for blood and saliva samples, but we only need to do centrifugation, and that's sufficient, right? No special filtering for urine samples, for instance, right?
Correct. In the work that I did, we didn't do any pre-filtering for the urine. We just spin it down and collect the supernatant. And with the blood and blood plasma and saliva, we added the precipitate and then spun that down, collected the supernatant, and directly put that into the analyzer. I do know that some labs will filter their samples first. Mm-hmm. We found it to be unnecessary by spinning it as 8,000 RPM. It didn't seem that we needed to do the additional filtering step.
Okay, that's pretty impressive. And did you find out that working with biology, you needed to do more frequent exchanges of the injection blocks than you would do with natural water samples or things like that?
That's a very good question. And yes, you definitely want to. It's urine and saliva, they're just really sticky. There's a lot of gross stuff in there, and it's just really sticky, even though you go through the spinning process. So it will get your block dirty a lot faster. So I recommend shorter runs and wash the block every day. That's why we provide an additional block with the analyzers. So there's really no downtime. While one block is being used, the customer can be washing the additional block so that the next morning they can place that one on and then just switch back and forth.
Okay. Okay, perfect. Thank you, Susan. Are there some questions for Susan, this application?
So let me understand, is this targeted for pathological testing agencies or labs? Is that the market?
People that are interested in total daily Expenditure. I think that's the biggest market for this. Correct me if I'm wrong, because I'm not on the application side of things, Fred.
Yeah. Yeah. Well, we typical customers, Teshbir, would be well. First of all, we have customers working in biomedical research institutes, working on understanding the metabolism, evolution of the metabolism of different people, especially people with obesity problems. So it could be academic hospitals or biomedical research would be probably the primary target for this kind of application.
Okay, thank you.
And by the way, I asked, we have extended a little bit. If you want to show maybe Susan also the slide just before showing the isotopic CO2 application. As Susan mentioned, this slide is not directly related to stable isotope waters, but we wanted to broaden a little bit the scope of the webinar to show that we can also use the ABB LGR isotopic instruments to do energy expenditure applications on CO2 exhaled from human or animals. So this slide here is another energy expenditure application, which has been developed by one of our customers, and you see the black box here is our ultra portable isotopic CO2 analyzer that they use to measure and understand the metabolism and respirometry of either animals or human beings, and which they integrate. It's our customer. Sable Systems International, who is integrating this instrument in their respirometry suits. So some private companies could be also interested, of course, in our instruments, but most of the applications so far, or a lot of the customers for either isotopic water applications or isotopic CO2 when it comes to energy expenditure, have been hospitals or biomedical research organizations.
Let me just add a little bit to that. Then, a lot of times when we talk about energy expenditure, that's a euphemism in many ways for diabetes studies. So a lot of these studies that are going on in medical research labs and institutions are looking at glucose metabolism and studying the effects of diabetes on patients who are either have diabetes or are pre-diabetic, and this helps them understand how they metabolize sugars. So yeah, that's one thing. So another way to think about potential sales targets. Anybody who's using an IRMS for water study, doubly labeled water, should absolutely have one of our instruments. And what Susan said is that, we did a careful study that demonstrated, and it was published in a peer-reviewed journal, the equivalence of our system versus the IRMS. So no reason to use an IRMS at all for these type of applications. And oftentimes the customers who are doing these applications are using their instrument full time. So the argument for, well, the IRMS can do other isotopes doesn't really hold, because their instrument is used for full time on that particular application. And then and it's obviously cost they save a lot. So it's not only less expensive to own, but less expensive to operate. And then and service, as Susan pointed out.
Yeah, thank you, Doug. Any other question? I'm just going to check in the conversation. I don't see questions in the conversation. Well, if there is no further question, first I'd like to thank Susan again for the presentation, and especially she was not going to present initially, and she stepped in basically yesterday because another colleague was ill yesterday and today. So Susan kindly stepped in to do the presentation in addition to the technical session. So that's really appreciated. The webinar has been recorded, so you will receive a notification within the next few days when it's available on the ASN website. Together with the notification, I will share with all the invitees. I will share a PDF copy of the slides, and you will be free to share them with your customers as well. And the articles which have been mentioned by Susan, as I said, can be available. You just have to send an email to me. And that webinar was a conclusion of our series of webinars on isotopic water applications. But in the future, of course, we will organize other technical webinars featuring other applications of the ABB AGR laser-based analyzers. So with that, I would like to thank everyone for your time and attendance. And again, feel free to come back to us afterwards if you have further questions, or also if there are some specific topics that you would like us to address in future webinars. We'd like to hear about that. So thank you very much, Susan, and thank you very much, everyone, for attending. Bye-bye.
Thank you.
Thank you. Bye-bye.